this video, we are going to use Pascal's triangle in order to expand binomials or multiply binomials together more quickly. So Pascal's triangle looks like this. We've got a triangle of numbers. At the very top we have 1, and we call this the 0th row. Then underneath the 1 we have another 2 ones. And the easiest way to build this triangle out is that the 2 numbers that are above the one in between below, all you have to do is add them together to get that number. So 2 plus 1 is 3, or 3 plus 3 is 6. So let's go ahead and add together some more numbers in order to get the 5th row and the 6th row as well. So I will always start with a 1 on the outside. If I do 1 plus 4, that gives me 5. 4 plus 6 is 10. 6 plus 4 is also 10. 4 plus 1 is 5, and then I'll end with a 1. Okay, if I do the same thing for my next row, start with a 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then I have a 1 to finish. So that's how you build Pascal's triangle. You just start with a 1, add more 1s, add things together. So the reason that this matters is you may look at the 4th row here. Okay, where we have 4 also in that row. And if you were to look at this polynomial here, this binomial that's been multiplied, if I took x plus y to the power 4, so if I multiplied x plus y 4 times, x plus y times x plus y times x plus y times x plus y, I would get this polynomial, x to the 4th plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the 4th. And what you hopefully notice is that the coefficients of your expanded polynomial are the same as Pascal's triangle for the 4th row. So if my exponent is 4, I'm going to look at the 4th row, and that will indicate the coefficients of every term in my expansion, which is super cool. The other thing that you'll need to pay attention to is what happens with x and what happens with y. So let's take a look at this more closely. For my very first term, I have x to the 4th. My second term becomes x cubed. My third term is x squared. My 4th term is x. And then my 5th term, I don't have any more x's. With y, I start with no y's. Then I have a y. In my 3rd term, I have y squared. My 4th term, it goes up by 1. Now I have y cubed. And then my 5th term, I have y to the 4th. So as you can see, x will start with the highest exponent, 4, and then it will decrease by 1 each time until there's none left. And then y does the opposite. It starts with none, and it will increase by 1 until the final term has that highest exponent, or the degree. All right, so let's go ahead and practice this. We are going to use this to practice expanding the binomial x plus y to the 5th. The first thing we're going to do is write down the coefficients. So I'm going to be using the coefficients for the row that has a 5 in it, or the 5th row. And I'm going to go ahead and write those down. I'll space them out. So I'll have a 1, a 5, a 10, a 10, a 5, and a 1. The next thing I'm going to do is I'm going to fill in the x terms. As I observed before, I should start with x, the first term in my binomial, and I know it's going to be to the power of 5. It will decrease by 1 each term, so x to the 4th, then x cubed, x squared, x, and then no x's. I also know that y is going to do the opposite. I'll start with no y's, then I'll have y to the 1, or just y squared, y to the 3rd, y to the 4th, and then y to the 5th. All of these terms will be added together. And hey, look at that. We've done it. We have expanded x plus y to the power of 5. All right, so let's try a more complicated one. This time, I have 2x minus 3 to the power of 4. Once again, I am going to start by writing down the coefficients of Pascal's triangle. Now, I have a degree of 4, so the coefficients I should use will be 1, 4, 6, 4, 1. I'm just going to write those a little bit more spread out. 1, 4, 6, 4, 1. Right? That's from our Pascal's triangle. Okay, next up, I'm going to focus on the first term, which in this case is 2x. So for my very first term, I should have 2x all to the power of 4. That includes the 2. It'll decrease by 1. 2x is now cubed. Then 2x will be squared. Then we'll just have 2x. And then we won't have 2x. Let's do the second term. In this case, that's negative 3. So I'll start with none. And then I'll have 1. And then it will be squared. And then cubed. And then to the power of 4. I'm going to add my addition signs in between each of these terms. And now it's time to simplify. I have 2 to the power of 4 here, as well as x to the power of 4, plus 4 times 2 cubed times x cubed, also times negative 3, plus 6 times 2 squared times negative 3 squared, which is 9. So I'm going to go ahead and multiply that. That's 9, okay. Plus 4 times 2x, well, that's 8x, times negative 3 cubed, which is negative 27, plus negative 3 to the power of 4, which is positive 81. So let's keep simplifying this. 2 to the power of 4 is 16. So I'll have 16x to the 4th, plus, this would be a great time to pull out a calculator, and I would do 4 times 2 cubed times negative 3, which is actually going to change the sign. So it's going to be minus, and when I multiply this together, I get 96x cubed. Then I'm going to multiply 6 times 2 squared, or 6 times 4 times 9. Oh, forgot to put my x squared in there. That is going to be positive 216x squared. And then I'm going to do 8 times negative 27, which is negative 216. And then I have my x plus 81. So it follows the same pattern. It's just a little bit more complicated with those numbers in there. And that's how it's done. Thanks for watching.